So we're going to talk a little bit about concentration and mainly about the units of concentration because there's several of them. So concentration is the amount of solute dissolved in a given amount of solvent at a particular temperature. There are several different units of concentration that we can use. You've already learned molarity, and then there's also some percentages. There's a percent by mass, a percent by volume, and a percent mass over volume. But they're just percentages, so they're just part over whole times 100. Molality, which is going to be new. Mole fraction, which we've seen a little bit of already, and it is exactly what it sounds like. It's a fraction of moles. And then parts per million or even parts per billion. So molarity, we've talked about, is moles of solute over liters of solution. So if it says 5m, I might say I have a 5 molar solution. Okay, so I might have 5 moles of solute per 1 liter of solution. Okay, molality, okay, so this is a capital M here. Well, molality is a little m, and I might say that I have 5 molal. A little hard to say, but there it is. So I might have 5 moles. I might have 5 moles per 1,000 grams of solvent. Okay, so it's different. It's not the solution, it's a solvent. I might have, say, 5 moles of, say, I don't know, sodium chloride dissolved in 1,000 grams, or, you know, that's 1 liter, right, of water. Okay, so not 1 liter of solution, but 1 liter of water. Molality is rarely used except for some colligative property calculations, which we'll get into in a little bit. And it's also the only unit with solvent as the denominator rather than solution. Okay. The percentages, so percent M over M, you can say percent by mass. The M just stands for mass, so grams of solute over grams of solution times 100, right? Which is part over the whole times 100. Okay, that's what all percentages are. Percent V over V is percent by volume. So milliliters of solute over milliliters of solution times 100. And then percent M over V, you might say percent mass over volume, is grams of solute over milliliters of solution times 100. So a couple things. When you write these out, you can't just say, oh, I have a 5% solution, because we won't know what you mean. Okay, so you have to literally write 5% kind of mass over mass. You have to tell the reader what you're doing. And then what about this one here? How is this different from density? This is something that students often compare with density because it's grams over milliliters and it looks like density. But remember, when you're doing density, it would be mass of sort of a substance over the volume of that same substance. Okay? Whereas here, we have the mass of the solute over the volume of the entire solution. So percent mass over volume and density are different things, and try not to confuse them too much. Mole fraction is just a fraction of moles, and you use this funny Greek symbol. You can just make it like a fancy X if you want to. Okay, so the mole fraction of A is the moles of A over the moles of A plus moles of B, or you can say moles of A over total moles. The mole fraction of B is the moles of B over the mole fraction of, over the moles of A plus the moles of B, or again, the moles of B over the total moles. It's just a fraction, all right? So it's kind of the part over whole without the times 100, okay? Now, even though it's called a mole fraction, it really should be reported to as a decimal to the right number of sig figs, okay? So try not to write your fraction as a half. Instead, write it out as a decimal so you can show the right numbers of sig figs. And then the last couple are parts per million and parts per billion. They're a lot like a percentage. It's part over whole, but instead of multiplying by 100, we're going to multiply by 1,000,000 or 1 billion. And these are generally used for solutions with just teeny tiny amounts of solute. So something that is 5 parts per million, okay, has 5 grams of something in like 1,000,000 grams of solution. Okay, so it's teeny tiny, but you'll often see them in newspaper articles and stuff. Usually when they're trying to scare the public by saying there was 50 parts per million of this in there, not hoping that nobody would notice that it was a parts per million rather than a percentage. Anyway, so those are the units of concentration, and we'll be using them on and off in different places.